Hey guys, let's analyze this problem, which you have a pulley, and then the pulley is there's a string that wraps around the pulley, and then the string is connected to a mass. Okay. Now the mass is falling, can fall, under the influence of gravity, and its motion is downwards. Okay. Now as the mass falls, the pulley rotates. So this problem demonstrates rotational motion. Okay. And linear motion as well, and in this case it also demonstrates how you can have a system in which they both are connected. Okay, rotational motion of the pulley is connected with the translational motion of the mass. Now it's a system like this, right, where as the mass falls down, the pulley rotates. Okay, and we'll assume that the pulley is a solid disk. Now the first thing we can do is to look at the forces acting on the block. So there's tension in the string, and then there's the weight of the block. The tension acts over here also. The tension is the reason the pulley is rotating. So tension, you can say, that provides the torque to rotate the pulley. Okay. Now let's look at how you can solve this system. Okay, I'm not going to put in numbers, but we will just look at the strategies that you use to solve this system. Now we can first write Newton's second law for this mass and Newton's second law of rotation for the pulley. Okay, so let's do that. So for the mass, Newton's second law is, so F net equals mass times acceleration. The net force is downwards, so W minus T equals mass times acceleration. That's for the mass. Now for the pulley, you will apply, so this is F net equals mass times acceleration, and this is tau net equals I alpha. Okay, since the pulley is a rigid body, you need this form of the law. So then what we'll do, so that there's only one force acting on the pulley that's rotating it, right? That's tension, and it is acting on the edge, which is the radius. It's the distance of the center of the pulley to the edge. So you get tau net equals I alpha, means since the tension is tangential, it's just the angle between tension and the radial vector is just at this point is just 90 degrees, and at all the points is just 90 degrees. So just T times R equals I alpha, and it is counterclockwise rotation, so you get positive sign over here and positive sign over here. Also, because alpha is also positive, the pulley is speeding up. Alpha and omega have the same sign. So this law that you can use to find the direction of omega, and if the pulley is speeding up, alpha points in the same direction. So the net torque is therefore this. And we're assuming that the pulley is a disk. So for a disk, I is half m pulley r squared, right? Now we can, and you should also know that the tangential acceleration, remember the pulley has tangential acceleration also. The tangential acceleration is the acceleration of the mass, right? Is equal to angular acceleration multiplied by the radius of the pulley. So we can plug this in over here just to simplify this equation more. So we can write this as T R equals IA divided by R. So that gives you T equals IA divided by R squared. Now you can see that this is the mass of the pulley, okay, MP. So we can divide this expression I divided by R squared. You can see is half of MP. Okay, so you get half of MP times A. Okay. So this is the tension of the string. Okay, this is the tension in the string. Now you can plug this in over here to get. Let's call this 1 and 2. Let's plug 2 and 1. So you get W. Let's write that. Plug 2 in 1. So we get W minus half m pulley times A equals m times A, right? So you can further simplify this to get A equals W divided by m plus half of MP. Okay, I've just taken this on this side, take A common, and then divide both sides by this factor. You get this equation. So this is the acceleration of the system. So another way you can solve this is by using conservation of energy. Okay, so you can let's say that the block falls a distance h. Okay, it starts from rest and falls a distance h. So mgh is converted into. So let's quickly draw that. So let's say that the block starts here and falls distance h. Okay, so from conservation of energy you get mgh. This is the mass of the block, equals half mv squared plus half I omega squared. Okay, so you can also simplify. Remember, the velocity equals r omega, right? So this is the tangential velocity also of the wheel. The velocity of this guy, right, is also the tangential velocity of the pulley. Okay, so you can therefore plug this expression in to simplify this. So you get mgh equals half mv squared plus half I is equal to half mp r squared. So r squared omega squared. So you get mgh equals half mv squared. It's 1 by 4 mp v squared. Okay, so you can then take v squared common and then divide both sides by this. So you get v squared equals mgh divided by half m plus 1 by 4 mp. Okay, so that's your velocity. So this is how you can get the velocity of the mass. Okay, which is also the tangential velocity of the pulley. So this is just a quick overview of how you can solve this system. Again, in summary, you can apply Newton's second law and find the acceleration. If you know these masses, you can get the acceleration. Once you have the acceleration, you can use those equations. V equals v naught plus at, and the other equations, v squared equals v naught squared plus 2a delta y. So you can use all these equations to find the velocity of the system. Okay, and you can also apply conservation of energy. That's another method that you can use to solve unknown variables in these type of questions. Okay, so this was it for this question, for this problem. Let's if you have any questions, post them in the comments, and please subscribe.